Good evening, everybody. This is the notes for section 3.1. Starting chapter 3, it's all about parallel and perpendicular lines and everything associated with them. In this first section, we're going to be talking about some specific types of, lines, pairs of lines, and most importantly, some types of angles that we're going to be using for a long time. So this is, as far as geometry class is concerned, this is a pretty important section. This and the next one. All right, let's take a second, copy down these couple definitions here. The first one, parallel lines. I think everybody knows what a parallel line is. They're just lines that do not intersect. But we actually have two different terms for lines that don't intersect. And the key difference is, with parallel lines, they are coplanar. They have to be on the same plane, and they don't intersect. Okay, the other type of lines that don't intersect are called skew lines. This is that second definition. Skew lines don't intersect, but they're not on the same plane. So think about a line that's on the ceiling, think about a line that's on the floor. They could be going in completely opposite directions, but they're never going to cross. One is on the ceiling, one's on the floor. They don't cross. That would be an example of skew lines. Parallel lines, they're on the same plane. And we also have this idea of parallel planes, just planes that don't intersect. So again, think floor, ceiling. They don't cross unless you're in some weird, some weird room. Charlie and the Chocolate Factory, that's what I'm trying to think of. One of those little hallways that goes into a very tiny little door. But that's not really important right now. So let's take a look at this drawing. It says, think of each segment in the diagram as part of a line. Complete the statement with parallel, skew, or perpendicular. So hit pause to try to answer these. Okay, for the first one, WZ and ZR. WZ, ZR, those are on the same plane, but they're also intersecting. If this thing is a box, a perfect box, these things are perpendicular. I'm just going to write the symbol for perpendicular. They're intersecting, so they're not parallel, they're not skew, so they're going to be perpendicular. Line WZ and line ST. Okay, WZ is this red one, line ST. These do not cross, but they are on different planes. That is skew. Oops. All right, line QT and YS. Oh, line QT, you're so tiny, little cute line QT. YS is over here. Again, they do not cross, but they're not on the same plane. So, skew. All right, plane WZR. That is the front of this box. Plane WZR, we're looking at this green plane, that's the front. And plane SYZ. SYZ is the side of the box. Those are perpendicular to each other. The last one, plane RQT, that is the bottom of the box. And plane YXW. YXW is the top of the box. So the top and bottom of the box, those are parallel. All right, that's the idea for those terms. All right, these two postulates, again, take a second to copy these things down. Okay, again, you do not need to know the number, postulate 13, postulate 14. That's not important. You may want to copy it down just as a reference in the homeworks, but the names, those are important. The parallel postulate, it says, if you have a line, line L, and some point not on the line, it doesn't matter where it is, it's just not on that same line. The parallel postulate says there is exactly one line that goes through point P parallel to line L. So you got a line and a point not on the line, there's only one parallel line through that point parallel to the original line. The perpendicular postulate basically says the same thing. If you have line L and some point P that is not on that line, there is exactly one line that goes through P perpendicular to line L. We'll use these eventually. The parallel postulate, we'll use these in proofs of triangles. But for right now, it's a postulate, know the name, know what it says. All right, this stuff, second video. Bye.